Hi everyone, today we're talking about statistical questions. You do not need to write down everything we'll cover in this video, but be sure to jot down important information and at least one example of each type of problem that we'll cover. Also remember that you can pause the video to jot down important notes, rewind to view information again, and fast forward if you think you got it. But be careful, make sure you don't fast forward so much that you miss out on something important. So when we talk about statistical questions, we first have to talk about what statistics even is. Statistics is a form of math where you gather data, organize that data, analyze the data, interpret the data, and present the data to draw conclusions in order to answer a question that you're curious about. So kind of think about it as scientists using math to figure out a problem. So you know in science that you first have to ask a question and come up with a hypothesis. And then you have to test your hypothesis by gathering information, right? So statistics is kind of the math that helps those scientists make sense of their data. So just like a scientist, you're going to gather data to help you answer that question. But then you need to organize your data. So that's where we're going to talk about graphs and stuff. Then you're going to analyze your data. So meaning you're going to basically take another look at your data and try to, figure out what's going on. And then interpreting your data means you're going to now use what you figured out from your data to try and answer that question that you were curious about. And then presenting your data would be like kind of drawing a conclusion for your readers. Okay, so a statistical question. In statistics, we have to make sure that we're not just asking any type of question. We're asking a statistical question. So what do we mean by that? That's a question that can be answered by collecting data. So if your question can be answered without collecting any data, it's not a statistical question. Like if I ask you, what color are your eyes? I can just look at you and figure out what color your eyes are. That doesn't really count as collecting data. Collecting data would be like going to different people and asking them a question so that you have a whole bunch of data at the end of the day. And then the second is the question has to be answered where there's variability in that data. So I'm going to have a whole bunch of data that I'm collecting from different people. And what we mean by variability would mean that everybody's answer is a little bit different from each other. So if I ask the question, how long is math class? And you say, well, I can collect data by asking everybody in my class. Yeah, that's correct. But if everybody says 1 hour, then there's no variability because everybody's saying the same thing. So not only do you need to collect data from different people or different places, but there has to be variability, some change in the answers. Because if everybody's saying the same thing, then that means there's one correct answer. So statistical questions don't have one correct answer. There's a whole bunch of different answers that could make sense. Make sure you copy this down, and I'm going to give you some examples. All right, so here are some examples of statistical questions. So remember, these are questions that I can gather data from, and there's variability, a bunch of different answers. What do 7th graders prefer to eat for lunch? So if I go around and ask different 7th graders, they'll each tell me something a little bit different. Yeah, some people will have the same answers, but overall there's going to be a whole bunch of different answers that I can examine later on. What time did the students in this class get up this morning? Some people might say 6 o'clock, some people might say 7 o'clock, some people might say 8 o'clock, some people might say 6:45. So there's going to be a lot of different answers from different people for my data, and there's going to be variability. The third example is, what is the typical number of pets owned by students in my class? So again, I can ask a whole bunch of people to gather data. Some people might say 0, some people might say as much as 9 pets. So lots of variability. Examples of non-statistical questions. Remember, this means that I don't have to gather a bunch of data, and there's probably one answer. There's no variability. So if I ask, what did Tom eat for lunch? He'll probably say, a sandwich and a Capri Sun. Done. There was one answer. And it was true. There's one correct answer. Did you get up on time this morning? Well, that's either a yes or a no. One answer, no data collected. How many brothers does Martha have? She'll give you an answer, and that's it. There's no collecting of data. There's no variability. So those are your examples of statistical versus non-statistical questions. Make sure you write down some examples. All right, let's go over a couple of examples. So this question is asking whether it's a statistical question or not. How many boogers does Carissa the ogre have in her left nostril? Go ahead and pause the video and try it on your own first. Okay, so Carissa the ogre. Does she need to collect data for this from a whole bunch of different places? Maybe she just picks her nose in her left nostril, right? That's not really a whole bunch of data that she collects. And is there only going to be one answer? Yeah, there's only going to be one answer. It's probably going to be like 3 or something. So if there's only one answer and you don't really have to collect data, it's not statistical. So you should have picked not statistical. One more. For this question, they want to know if it's a statistical question. Does it typically rain more in the United States or in Brazil? Pause the video and try it on your own first. All right, so the key word I want to look at is actually typically. Typically means that somebody's asking like on an average day, or if I were to compare any random day with another. So that means that you're looking at what I like to call behavior. Like what's typical of somebody. So when you're looking at something that happens over time with behavior, that means that you're collecting data. Right? Because on a typical day, it could be December, it could be April, it could be March, it could be November, it could be any type of day like that. So if I want to know the general behavior of a country like the United States or Brazil, I'm going to need to collect data over time so that I can figure out on a typical day, on any day that I pick, and compare United States and Brazil, what's going on there, where does it rain more. So I'm collecting a whole bunch of data. I'm probably collecting data from random days between January all the way into December. So there's a lot of data there to collect if it doesn't say what day in particular. And since I'm collecting all that data, there's going to be a whole bunch of variability. Maybe in January it doesn't rain that much, and then it rains a bunch again. So your answers are going to go up and down. There's going to be a whole bunch of different answers. So this question right here would be statistical. Okay, let's do one last one, and we'll just read this here. So it says it's not statistical because the question can be answered by collecting the average rainfalls in the United States and Brazil. It is statistical because it requires collecting data with variability. On any given day, it's going to rain different amounts. Okay, let's do one last one. How many acorns do squirrels typically eat in a day? Go ahead and pause the video and try it on your own. Okay, so that says how many acorns do squirrels typically eat in a day? And it says squirrels, so they're comparing many squirrels together, right? If I just ask how many acorns does this squirrel eat in a day, you'll just say like 5. This one squirrel here eats 5 acorns in a day. But they're talking about more than one squirrel, so we're going to be collecting data from different squirrels, just like how the previous one was to 2 different countries, right? So we're going to not only collect from different squirrels, but we're going to collect information on different days. So that's a lot of information. And then there's going to be a lot of variability. So maybe some squirrels eat a lot, other squirrels don't eat that much, some squirrels eat in the middle, lots of variability, differences in the answers. Also the keyword typically. because that's telling us that we're looking at some kind of behavior that kind of changes over time, but we're looking for something that's typical of their behavior. Okay, so this would be a statistical question. All right. Let me know if you have any questions as you work on these problems, and I'll be seeing you in class.